Here goes. The next example is we are going to integrate x multiplied by the square root of 1 plus 2x squared with respect to x. I'll see if I can just sort this focusing out a minute. And we are going to, or we are told that u is going to be 1 plus 2x squared. And somebody said yesterday, are you always told what the substitution would be? And I said yes. If you look back at the questions we've done, it's often whatever makes it nasty, that's what u is. So here, the nasty thing is this thing here. I guess it's being square rooted, but the nasty thing is coming from the 1 plus 2x squared. So that is what our substitution is. So, what did we do first off yesterday when we had the substitution? What did we do? Well, I know we did it slightly differently on one question, but what generally did we do?
Put it as x equals.
Put it as x equals. Brilliant, thank you, yeah. So we put it as x equals. So over here, if I take 1 away from both sides, that will give me 2x squared. So if I divide that by 2, that will give me x squared. So if I square root that, that will give me x. And it might be more useful to write that down in index form. Because, as you correctly said, once we get it as x equals, what was the next thing we did?
Rewrite question.
Divide it, yes, divide it, or dx du, we differentiated it to get dx du. Okay? So here, I've got to differentiate that. It might be easier to rewrite that first of all before you differentiate it. If I wrote this like this, are we all happy that that is the same? You should all know how to differentiate a bracket like that. And by rewriting this like that, I've made it look more like this. So before we do that over on the right, can somebody just tell us how we differentiate this thing over here? And we'll use that over here. Yeah, okay. The powers come down the front. The amount of x's, the coefficient of x's, that's come down the front. Bracket stays there. Knock one off the power. So that's how we differentiate something. So rewriting this to make it fit that rule, we should now, hopefully fairly straightforwardly, be able to come up with dx du. What will my a be over here? Half, yeah, it's that thing there in front of the u, so half. What is n? Yeah, it's that power up there, that's a half. Then you have the bracket written down. And then you take 1 off that power up there. Okay? So we differentiate it and we get that. It might be nicer to rewrite this in this style up here. Because actually it does look nicer, sort of less ink up here, it's written more nicely. It might be nicer to write it like that. So let's just rewrite that line. What's the half times the half? Yeah, so we've got a quarter. And then this bracket here is just that. So I just changed it into that, so I can just change it back again. That's u minus 1 over 2. That's another way of writing out that bracket. It's what we had up here. And I'll put the minus a half there. And when we have differentiated it, then, what's the next step?
Rewriting the equation.
Yeah, go to rewrite the original question. So I'm going to have to zoom out here to see it, unless I write it down again, which might just be easier if I just write the question down again. Otherwise we're going to have things miles apart on the screen. So that was the question. So I am integrating x. Well, x is this up here. First time I wrote x down. So x is u minus 1 over 2 to the power of a half. That's x. Then I've got 1 plus 2x squared. What's 1 plus 2x squared the same as?
U.
Yeah, that's right from the top. That's the same as u. But it's being square rooted, so that's got a power of a half. Now over here's one thing I didn't actually do here. Just from this one over here, I didn't actually just write down what dx is. And to get dx on its own, I just need to move that du up here. I'll just write it down, just for the sake of completeness, so everybody can see where that's come from. Okay. So if dx is that now has to be written down to replace that dx. I wish I hadn't put that line there, no? Never mind. So I've got a quarter, and then u minus 1 over 2 to the power of a minus a half du. So that finishes there. And whilst that looks quite ugly and messy, can anybody spot things that happen there which help us out?
It's the minus 1 over 2 and to minus 1 half, which is the first half.
That and that are the same bracket. They're being multiplied together. So when you add the powers, it'll be that bracket to the power of 0, which is 1. So they disappear altogether. That's what's good about it. That's why you were guided down that route. So we are left with a quarter, which is just a multiplying number, so I might as well take that through the integral sign. And then all I'm left with is u to the half du, which makes the question much simpler. Now I would do the integration. Can anybody integrate for me, please? U to the power of a half du.
So the 3 u's and the 3 over 2.
Yeah, u to the 3 over 2, that's adding 1 to the power, dividing by the new power. I'll put that in brackets. I've done my integration at this stage. What should I do? Put a plus c on. Yeah, okay. Nothing wrong with what you said there, but okay. Dividing by 3 over 2 is the same as timesing by 2/3. So that quarter there, I could, instead of dividing there by 3 over 2, times that by 2/3. And then I've got my u to the power of 3 over 2 plus c. We all happy with that so far? How can I simplify the fraction? How can I combine those fractions?
6.
Yeah, 2 over 12, which is a 6. I shouldn't be leaving any u's in my question, in my answer. I didn't have any u's in my question. U was 1 plus 2x squared. So that is to the power of 3 over 2 plus c. And the last thing is being quite fussy. But in my original question, did I have an indice like this, a fractional indice? In the original question, what did I have instead? A square root sign. So just to make it look more like the question, that means 1 plus 2x squared is being cubed and then square rooted. There's absolutely nothing wrong with the line above at all, but it just makes it look more like the question. And an answer book may well present you with this version of it here. And that is that question finished. I'll stop filming there at that point.